Okay, review session. First thing first, okay, in the last months, basically we're dealing with two-way factorial, and consider three-way factorial is a expansion of two-way factorial. Agree? So let's start from a three-way factorial is if you have A, you have B. Oh, okay. You have A, B, C. Okay. Then you need to do what? Start from -1, -1, 0, +1, right? Okay. 0, +1. And then you need to run this, right? 3 by 3 by 3, 27 times, right? And if A is like this, B should be what? 3, -1. 3, 0. And 3, +1, right? And then this things, and then of course the last one will be 9, +1, 9, -1. Okay, and why I'm emphasize this is we talk about orthogonal. How to be orthogonal. How to be orthogonal. How can we say that, hey, this experimental design is an orthogonal design, no matter two-way or three-way? There are a couple of things need to be there. One is what? Since it's a contrast by itself, should be what? Two sides of the wall, so the sum of this whole things, the sum of this whole things need to be 0. So, and then if the sum of it by itself is 0, is that good enough to claim they're orthogonal? Is it? You're not. You're in trouble. If the sum equal to 0 only says that it's a contrast, need to be what? Vector 1 dot vector 2 is 90 degree. Right? 90 degree means that it's vertical, it's orthogonal. And how to be dot equal to 0? The product of the sum of any two of them. So sum, product, so AB interaction, AC interactions, any two of them need to be 0. So I can try AB is 0, AC is 0, and I can say, what about AC? What about AC? AC should be 0, right? And actually, what if, any one of them is not orthogonal, then you're in trouble. And of course, once you have this, you can use all the template developed for three-way, two-way, calculate your sum of square, get your ANOVA table. Okay? So there are homework example. You just need to make sure you have your template ready for that. Okay? And the next things is that in the exam 1, I said that, you can see the world using Central Station, subway station. You can use the regression. And the regression, you can use the 0-1 approach or the -1, +1 approach. Let's just tell you how to see the world. There are many different ways. But in exam 2, our focus is always orthogonal. And in order to get your orthogonal, it's always +1, -1, or +1, -1, 0. Okay? And that's the most important thing that before you plug in and then you get your sum of square. Okay? The next things I would say is important is that I didn't do much in the three-way factorial because three-way factorial is just extension of two-way factorial. Is I start saying that, I can have an experimental design, okay? And I say that, I can have A effect, and then I can have A effect, positive, negative, right? So I can have A effect, where is it? I can have A effect, positive, negative. And then I can have B effect, positive, negative, right? And of course, I'll have negative and positive. And then I can have A effect, negative, positive. Okay? And then, of course, that will create your positive, positive, negative, negative, positive, negative. The 4 dimensions. Okay? And that's 4 trials. And then we can 4 become what? A trials. So if I have A trial, I can say that, I have this, I have to do it twice. First time, this block, yellow block, C is all positive, or is this block C is all negative. Okay? And what's the problem of having the block similar to your main effect, or the same as your main effect? What is that problem we call? Confounded. Because if I said yellow block and beige block, here C is all positive, or here C is all negative. So the contrast between positive C and negative C will be the same effect as your yellow block versus your beige block, right? So what we said is, do we usually use your main effect to separate your blocks? No, we tend to use the the high level interaction. I'll use A, B, C, D, E to separate that. Okay, so and the second thing is that I already done it in the class, is that you can have one blocks and then another blocks, and said that, okay, really this is your homework, right? This is really a full design. But if I separate them into the 2, okay, you a lot of time facing this issue, right? Say A is very significant in this block. Probably A is very significant in this block. And probably A is very, very significant when I try to put them all together. Okay? So if I combine everything together, If A is a significant, the main one, probably A is good. A is good using a fractional factorial design. A is very good in the fractional factorial design. Okay? Usually that's the case. Okay? If it's not, you already know that something is fishy in the blocking. Okay? But after that, okay, for example, after that, the second significant effect is AD effect. So AD effect is important here. AD effect should be important here. And AD effect should be important if you're using everything. Okay? But remember I did the elbow plot? Whenever you find something, A is a significant, AD is significant, you immediately know that, the logics in the sum of square computation got a little bit of differences. What's the differences? Can you talk about AD interactions without D involved in the game? So immediately you should start thinking about, hey, if I need to include AD, I need to have what? D there. You follow me? So because of this, I'll say that this already says that, hey, if I want to have D, sum of square did not have D as my number 2. Okay? And there's a problem. So let's just play for fun. Okay? Then after that, give me the third one. If the third one is D, that'll be nice, right? If the third sum of square, big one, is D, that'll be nice. Why? Because now A is in, AD is in, D is also in. So I have main effect in two-way interactions. I'm happy, right? But what if the next one significant is B? So what you really need to do is what? Keep going until D shows up. Okay? And let's say that D shows up after CD. So D is number 5. Okay? And if D is number 5, what does that also say about this whole games? Okay? So now you said that, hey, I have to include D because D is significant. Can you include D and CD not complain and say that, hey, I'm doing better than D. How come you have D, but you cannot exclude CD? So now you have to include CD. But if you need to include CD as an interaction term, you need to find what? Where is C? If C is right below, then happy. You guys follow me? It's always catch the main effect. Well, time out. Always, when you do the blocking, try to use the high-level interaction term to do the blocking. And when you finish the blocking, you will say that I can use the base block, I can use the gray blocks, or I can use the whole things. And hopefully they agree all together. Okay? And if they all agree together, usually, okay, using the full factorial design, you probably will have all the nice things happen early. Okay? So in other words is that, okay, pop quiz. Young lady, okay, if I have a 4 factorial design, I got 6 significant stuff. I don't care. It could be 2-way, could be 1-way, could be everything. I have 6 of them. So does that say that in the partial fractional factorial design, I should have 6? Usually should be more or should be less? Less. Why? Because I have less data to my lenses has less repetition to have the resolutions. So usually if you have 6 here, I could end up somewhere only 5 or 4. Okay? Then the sequence probably very similar. So in other words, if some A is good in the main, A should be good in the partial. But what is the real consideration here is that then whenever you see an interaction term show up, you have to say, hey, I want to let this guy play, the two-way interaction play. If you say I have to let a two-way interaction play, remember I said you cannot logically talk about, hot and sour soup or the interaction between hot and sour. Before you talk about the interaction, you need to make sure that you understand what is hot, what is sour. So if you want to have AD in, you have to say A must be in, D must be in. So A is in, so I'm happy, but D is not in, but D is in far behind. Then if you let D in, what will happen to the people before D? They'll say not fair. And then if they say not fair, you need to keep them in. But if you keep them in, you need to start saying that, where is my main effect? Did I left them behind? Okay? And whenever we're doing this kind of, negotiation after you've done your spreadsheet, I will have one recommendation. I said this since day one. Do I like to include a lot of player, or I like to include as few player as possible? I like to include as few as possible. Okay? And the principle is called KISS principle. Keep it simple, stupid. The principle of parsimony, the Occam's razor, or about the same argument. Okay, you will have this argument in Bayesian class, in reliability class, in almost all the classes. Because system engineering, we're talking about things that sometimes from very, very different discipline. And include more people only mess up the picture. Okay? So this is the second thing after you got your homework done. When you look at it is, I'm pretty sure, okay, once I give you the data, everybody can plug in the data and then have your sum of square ANOVA done. And then if I said, hey, I need you to run the residual for Durbin-Watson using regressions or using, do a, what's that called? Bartlett test for equivariance. Everybody can just follow the mechanism, okay? But I need you to have some logic thinking behind this or that. Okay, and technically speaking, I would say that, remember we can say, I can repeat this 3 times or 4 times rather than doing this repetitions. I have repetition in, so I basically have a fractional 1, fractional 2, fractional 3, fractional several times. And why usually we want to run fraction again and again? A lot of time is I'm already here. Why we want to run fractional in the first place? Why we want to run fractional experimental design in the first place? Yeah? Huh?
It's cheaper.
Yeah, it's always, no time, no money. But now if I said, hey, I'll let you run this, I can allow you to have year 1 budget, year 2 budget, do it again. And what will be the major concern is if I'm using, usually we say I'm using high-level interaction term as my block. So if I'm using ABCD as my my block 1, and I said, for repetition 2, can you use a different term? What happened here? Okay, yeah. So if I'm using this for my first block, so the generation, I said that, split the A, B, C, D, E, positive in one block and A, B, C, D, E negative in another block. Okay? So if I'm doing this, and then the second one, I say, hey, you know what? I give you extra money now. You can do it again. Rather than doing A, B, C, D, E block again, can I use, say, C, D, E, F as my second block? A second to separate the two blocks. What's the benefit of using different thing to generate the fractions? So I can still have a little bit of computation for A, B, C, D, E, the confounding effect, okay? But if you're running this, okay, you need to be careful on those, I have some partial here, I have some partial here. You don't have full resolution for the high level term, okay? And similarly, okay, if you say that, I'm going to run this A, B, C, D, E for 4 blocks, okay? And I'm going to separate them into 4 blocks. You need two high-level interaction to do the separation, right? So if, say, I have C, D, E, F, G, and this one I have E, F, H, J, K, okay? People need to remember, if I separate things using 2 generator to separate them into 4 blocks, okay, the confounding effect or the effect disappear, only these 2, or there should be more. Follow me? If I said that, C, D, E, F, G, I can have negative and positive, right? And then I can have E, F, J, K positive and negative, right? So now I can have positive, 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 negative, negative, positive. You know what I'm talking about. So I can use this to generate 4 blocks, right? One thing you need to remember, what is the critical things to remember? If I'm using 2 separate things into 4 blocks, I confounded C, D, E, F, G, I confounded E, F, J, K. What else? You guys follow me? Don't just do the computation of the homework. Okay, homework 1 is mechanism. Homework 2, there will be a lot of what does this really mean? If I confound C, D, E, F, G, I also confound E, F, J, K. That means I also confound what? C, D, G, J, K, right? Why? Because C, D, E times E, you got an E square, right? F times F, you have an F square. And G, nobody. J, nobody. J, K, nobody. So make sure that you understand, okay, if you separate a world into 4 blocks using 2, you're not just separating them, not just, so in other words, what you call the casualty? It is the, it's not your real cash. There in the military there is a term. Something casualty means that. Means that you separate this 2. This guys will automatically got confounded too. Okay. Everybody knows this. Yes, no? You don't? First time hearing it? Really?
So actually, when I saw the homeworks of everyone, the last assignment.
Okay, then let me do something here.
So fractional factorial, I guess, is what everybody wants to know.
Okay, fractional factorial. Let me just do this. ABC. Okay? Okay? So, one more time. -1, +1, and -1, -1, +1, +1. Okay? Okay, and then of course, this will be -1, +1. Okay. Now, people watch this. Can I use ABC to split them into 2 blocks? Yeah? No, let me do it differently. Can I use AB to separate them into 2 blocks? Sure, right? So I'll have AB, and this equal to this guy times this guy. Agree? So now I have A positive, AB negative. Are they orthogonal? Yes. Okay. Can I, using BC to separate them into 2 groups? So I can have BC, and this time will be B times C. Okay. So now I'm separating them as BC. Okay? Now people, watch this. So now I can use AB, BC to separate them into 4 blocks. Agree? So let's just do sort. Okay? Separate by AB, and then separate by BC. Okay, so now I have block 1. AB is negative, BC is negative. I have block 2. I have block 3. I have block 4, right? Everybody agree? Right? Negative, negative, positive, positive. So now, think about it. I have AB and BC. So what should be also blocked into this? AC. So if you look at AC, it's using A times C. Do you see that AC is either here or here? Positive, negative. So in other words, is that can you really talk about AC interactions without thinking about, see, AC interaction is the gray blocks and the pink block versus these 2 blocks, right? Everybody agree? That's the contrast.
Say that one more time.
Okay. Here. First, if I want to talk about AC effect, I have the AC positive and the AC negative. So I should use the gray block plus the pink blocks minus the beige blocks and the blue blocks, right? So in other words, is that the blocking differences and the AC differences are confounded. Agree? Here, let's start from the very, very simple one. Ignore everything's, okay? Cancel. Okay. Let's do a very, very simple one. If I'm only using AB effect, okay? I'm only using A times B, okay? And then, if I'm only using AB to separate the world, would you agree with me? AB, in fact, is confounded between the two blocks, contrast, the gray block versus the light blue blocks. So if I want to talk about the blocking effect and the AB effect, I'm really using the same computation in your Excel. Agree? Yeah? So you know that here only AB got confounded. But what I'm trying to say here is that, but what if I'm not using one thing to do the blocking? Actually, I'm using two things to do the blocking. So I have the AB and BC. So I know AB is buried in the blocking effect. BC is doing in the blocking. Okay, if I call this block 1, block 2, block 3, block 4. AB effect is really what? Block 1, 2 versus block 3, 4. Agree? Here or negative. Here or positive. So AB effect is the same as block 1, 2 versus block 3, 4. BC effect is the same as block 1, 3 versus block 2, 4. And then what is AC effect? It's the block 1, 4 versus block 2, 3. So here is the things that when you have several things get blocked, you cannot say that, Simon, you want computation, I give you the computation. This is exactly the same as homework A2 or A3. You need to think about this is, if you have two things blocked, you have some other things will get blocked at the same time. Everybody sees that now. Okay, that is something in the handouts I give you. They talk about the resolutions. Okay, those tables only for memorization, and I don't like memorization, so I'm not going to test you. Which one's which, because somebody already done it. But I would very care that you understand that whenever you have two things blocked, so in other words, if I have A, B, C, D, E block, and then I have B, D, E blocked, what does that really mean? Something else also get blocked. What is that something else also get blocked? AC, D, no, D is already there. So it should be only AC, right? Yeah? Only AC. And then, of course, if I have, say, three things get blocked, say I have a E and F, E and G. What does that mean? I did it in a class. So this two say what? This two say that who else will get blocked? A, C will get blocked. This two say what else will get blocked? B, DG. And this, say what will be a block? A, B, C, D, G, right? Right? Why they're not capital? Okay. So, blocking is because we don't have money, we don't have time. But blocking, there's a price to pay, it's confounding. And when you have several things blocked, you have several price to pay. And you just need to know that on one hand, you save some money, save some time, or at least get things done. But there is a price. You need to understand where is that price. Okay? Yeah. Don't just, plug and play and get the answer. You need to think about this. Okay? Okay. How about this? Question time. You ask me questions. Yeah?
Will you have stuff on the error term?
Yeah. Yeah. But error term, like I said, is straightforward mechanism. In other words, is that, we just check, did this thing follow the procedures? Do you have the autocorrelation? Do you have equivariance? Do you have the bell shape, QQ plot or Shapiro-Wilks? Okay? So those things, if I'm doing it, will be very, very simple. Just make sure you can do it. Right? You want to be a lawyer. You don't want to say that the evidence I collect, I didn't do it with the proper legal procedure. Yeah. So that part I don't consider is, all the residual analysis I don't consider is the main intelligence of experimental design, but it's the necessary evil, because it's very easy for you to design an experiment. You find all the excitement, but at the end, somebody caught you that you have one procedure, you didn't do it in the proper way, and say, oh, CDC said that you need to redo your experiment. We cannot accept your finding. Okay? So if I'm going to give you the residual analysis, because it's a procedure, I'm more care about, do you understand what's the procedure for, rather than it could be very labor intensive. That's why I need to make it really small. Yeah. Okay. What else? So, okay, let me make it clear, okay? I did not say that residual analysis is not going to be in the exam. I only said that I will try my best to make it not labor intensive. Okay, question?
In the homework, on homework 7, you asked for 2 power 8 minus 3, right?
Right.
How do we take the 8 factorial? Like, that thing is still confusing.
Huh. Here. A factorial, right? A. Yeah. Okay. Let's start from here. Can you see it? Okay. A, B, C, D, E, F, G, H. I have 8 now, right? So first thing first, I don't even remember what I have in the exam, but that's okay. Okay, first thing first, can you have, here is negative, positive, and then negative, negative, positive, positive. And then after that, four negative, 4 positive. And then after that, A negative, A positive. and then 16, 32. So 2 to the A should be 2 to the A. You should have 256, right? And for the 256, okay, you're not going to run 256 trials. And we say 2 to the 2 to the A minus 3, right? So A minus 3 is 32, right? Right? So what you're really saying is what? I need to find 3 interaction term to do the blocking. Because think about it. Here, split them into, so whatever the high level, say you use E, F, G, H, you separate them. Why I'm keep doing this? So, if I, what happened? Oh, here we go. Okay, if I use E, F, G, H, 256 split into 128 to 128, right? And then you use another one, split the 128 to 64. And then use another one, say you use A, B, C, G, to separate. So here you will have a 64, and I'm sorry, here you have a 128 run. And then here you split them into 64, 64, 64, 64 run. And then finally, you have one more to separate them into 32, 32, 32 run. And yeah, I can tell you, in the exam, I definitely won't let you run a 256 4 factorial design. So if I want to do something, should be how to pick, randomly a 132 design and use that fractions, or give you a fractions to speculate something. But young man, based on what I just explained to you, do you think what should be in the exam if I'm giving you as 3 if I give you a 2 to the A minus 3, okay, what should I really ask you to see if you understand this whole thing? You have the answer? Why not? Somebody. Use this guy to split the world, use this guy to split the world, use this guy to split the world. So finally I break them into 8 blocks, right? Right? And what will be the things that I'm worried the most? What did I just show you? If I use this, separate the block, I use this, separate the block, so I separate them into 4 blocks, right? So if I separate them into block by block, I say, hey, I say money, I say money, I say money. But something will be sacrificed, right? AB effect got confounded, BC effect got confounded, also AC effect got confounded. So in other words, the more blocks I have, the more things I'll get get confounded. So, young man, your questions. If I do a 2 to the A minus 3, what happened there? I say money, so I can run half, a quarter, and then cut it even shorter to have one of the 8 blocks. What is the problem? How many things get confounded or disappear? I use this 3. First of all, can you use this 3 to separate things into 8 blocks? Yeah? But do I care only those 8 things got separated into 8 blocks or what? Because of I separate them into these 8 blocks, there are other things also going to be sacrificed, cannot be investigated. Here, what are the things cannot be explained or investigated? It will be confounded. A, B, E, F, H, right? And this will be what? A, B, E, F, H, right? And then this and this. So you need to figure out that every time you play cheap, right? On one hand, everybody want to play cheap, right? I don't want to run. Here, in real life, do you really think you want to run 256 combination? Do you? Even you're doing a COVID medicine, you're going to make millions, billions of dollars. Okay? You would like to convince CDC you can get this done without trying everything, right? Right? So you're doing fraction of fractions. Okay? But there's a price to pay. What is that price? Things will get confounded and confounded and confounded. Okay? So that's one thing you have to understand is that if I give you a fractional factorial design, I will ask you what's the cost and benefit. You save money, but you lose the resolution of certain combinations. Show hands. Everybody understand the motivation? Okay, yeah. Don't just run the mechanism. The mechanism is important, but sooner or later, SAS will do it for you. I torture you because I need you to understand what's going on before I let SAS take over. But, you cannot just say that I can plug and then I have some number. You need to understand what those number can be used to deliver and defend it. Okay? Next questions.
I have a question.
Yeah.
So take example 8.3 that we were.
In the whole class?
Yeah, the one from like the example Excel doc that you uploaded.
Okay, let me see if I can find it.
Was referenced for like the most recent homework.
Okay, let me see if I find it. A3, right?
Yeah. I think it's that first one.
Oh, okay.
I'm not sure.
Should be.
Yeah, that's what it's called in
Okay.
on Canvas.
Yeah. So, A3? Yeah.
Yes.
Uh-huh.
Okay. So you're given those, you're calculating those sum squares.
Right.
How would you then take those and translate that to a note table?
Huh.
Confused on
Okay.
what
First of all,
represent.
yeah. Let's just use the upper blocks first. Okay? Now, upper blocks, what's the total sum of square? Sum of square total. Oh, sorry. Sum of square total is the sum of square of everybody, right? So sum of square total, this is the sum of square total. And then if I want to ask you the degrees of freedom, how many degrees of freedom? 1, 2, 3, should be 7, right? 8 minus 1. Agree? Okay. So far so good?
Would be 6. Because you have 1, 2, 3, 4, 5, 6, 7 minus 1.
No, I have 8
Oh, 8 observations.
Yeah. Yeah. Okay. So next, I can go upward, I can go downward. But let's just say that I want to build sum of square model. And sum of square error term. Okay? And this is the same analogy we had before. Now, for the sum of square model, we basically need to find the elbow point or find the few things that you want to keep them, right? So, based on this, well, let's do it the cheap way. Okay. Pays special transpose value. Okay, here are some sum of square A, sum of square B. I don't remember the name, but the things I will do is what? Data sort. Okay, and from the largest to the smallest. Dum. And then what will be the next things I'll do? Remember, you can have the smiley face, or you can plot a residual plot. Okay, and based on this, okay, how many you think you should keep? 4, right? Because if you have 5 in, you cannot drop 6. 6 will say it's not fair. But if you have 4 in, you drop 5. There's a big jump. So there's the elbow point. So far, so good? So we'll say that technically speaking, okay, technically speaking, I should have 116 is sum of square. Who is the sum of square? I should have sum of square 1176 is A, right? So I can have A in, and I can have sum of square 630. What is 630? AC. So I can have AC in. Okay, here is the tricky part. If you have AC in, immediately you should ask the questions. If I allow AC, who should be in? Both A and C should be in, right? But A already in, so C should be in. So who is the next? Huh? Next is AB? AD. Oh, okay. So next we should get in is AD. Okay? So, and what's next? I want to get it. So here comes another problem. AC is in, AD is in, but C and D both are not in. So now I need to figure out that what else should I be in? D is in. So next D is in. D is in, make AD happy, right? Because now AD can be explained. What is next one? Huh? C? Okay. So here is the things you need to worry about. Okay, let me finish that. Here. If you want to keep AD, D should be keep, and if we want to keep AC, C should be keep. Okay? So if I'm using the first block, okay, what will be left as my error term is I'm using 4. I only have 2 degrees of freedom left for my error term is sum of this 2. Agree? Huh?
Wait, I didn't.
Hold on. Let me do this. And then sum of square of my model is where's my sum of square of my model? Yeah, is the sum of 5. Okay. First thing first, young lady, would you agree with me? We always split our sum of square into two parts. The things we want, the model part and the error term. Okay? And we're using the building up strategy. Okay, who should be in the model? A is in. C is in. AD is in. But if originally you said, I want to keep 4, right? So I only want to keep 4. So I should, according to the elbow plot, I should only keep this 4. Tell me why I let a C in. Because of AC interactions. See, in other words, is that statistical sum of squares says AC, it should be there. But if I want to have AC logically, I cannot talk about hot and sour soup without the hot and the sour part. So I have to keep the C in. So let's look at the same argument one more time. This time when we're using the bottom blocks. Okay? If I use the bottom blocks, I did not do the sum of square. Oh, I do. So I have the sum of square here. So same thing. Control C. Control V. No. Paste special value. Oh, come on. Okay. Paste special value. Paste special value transpose. Shoot. Okay, delete. So again, I have 7 number here, right? But this time I'm not using block 1, I'm using block 2. Okay, for block 2, what will be the first thing you do? Do a smiley face or a, just look at it from the smallest to the largest. So again, the world into 2 sections, some model sections, and, let me just copy paste. Okay? So I have a model sections. Model sections, 722. Who is 722? 722 sum of square. Where is 722? I only have one sum 722, right? Or I have 2. I have 2?
A and AB.
Okay, good. So first thing first, who should be in? A and AD, right? Agree? So who SSA, SSAD. Okay? What's next one should be in?
AC.
And this time look at this. Let's do a residual plot. The smiley face, or just do a simple bar chart. Actually, this one is easy. I would say that no matter what, I need to keep 5, right? Right? And so if I need to keep 5, 684, who's 684?
AC.
Huh?
AC.
AD?
C.
AC? So far, the model, first 3, even though the sequence is not the same, but you know that AD and AC in. So you face the same problem is that, hey, I let AC interaction in, I let AD interaction in. Who else do I need to get in? Is C and D, right? And what's next? 544 is D, right? And then 392 is C, right? And so now the upper model and the lower model agree with each other, and the sum of square is just different number, but the main is in, the sub is in. This is not a tricky problem. What will be a tricky problem is what? Say I have AC in, but No, let me put it somewhere else. So it's not going to get confused with this one. Is what if, okay, when I have the model in, I have just two very heavy-duty interactions in. But guess what's the next main effect? It's SSB. Say B effects is in, okay? B effect is in before the CD interactions, okay? Then I'll say, okay, then I'll keep the B main effect, but as long as I can have the C and D in. But what if, okay? Okay? The elbow point showing that D is here. Okay? So, in other words, C originally not supposed to be in. The only reason I let A C sum of square in is not because sum of square C is big. It's because I need to explain things. So in other words, is that I keep SSC is because, not because it's big, it's because the sum of squares AC is in. Okay? You know, it's kind of like, hey, why I let you play? It's not because you're good. It's because, you know, you are part of the AC interactions. So if I want to talk about AC interaction, I need to keep C in. But if you let C in, but what happens is B is not significant. Okay? But SSB is greater than SSC. Now what would you do? Would you let B also in? You guys follow me? One more time. Here is the negotiation you want to talk about. AC interaction you want to be in. So A main effect should be there, C main effect should be there, right? Agree? So A is high, so A already in, no problem. C is not high, C is quite low. But because I said that, we don't want to talk about interaction unless we introduce the main effect first. So when you write your story, you say, okay, I need to let C in, even though C is tiny. But what will happen is, what if I have another tiny one, is B? Okay? If this tiny one, B, is below C, then I can drop it. I can tell B and say that, hey, you're not C in because AC interaction is in. So, you know, he jumped on the bandwagon because, you know, there's AC interactions in. But B can be eliminated. Here is the problem is that if I introduce C, but B is a little higher, but not significant. Can B said, you let C in, he's smaller than me. You should let me in. What will be your strategy here? You guys understand the tricky questions here now? How many of you say that B is higher than C, so we should let C in? Let B in. How many of you want to let B in? How many of you said that, no, we're not going to let him in? B out. How many of you think B should be out? You're right. For me, insignificant is insignificant. So I don't want to explain it. Whenever I can minimize my explanation, okay, here is my quote, okay? When in doubt, drop it. So whenever in doubt, I should drop it. So people, why I keep C? The only reason I keep C is because I have the AC interactions. Okay? So here, B even is higher than C, but if it's not significant, it's not significant. I'll drop it. Okay? That kind of logic is beyond just getting the computational done. Is you need to start thinking about, okay, here. If they're not upstairs, they should be in the error term, right? And you basically said that, well, there are a bunch of, according to the smiley face, the error term, they are down here. Only once in a while you say that, fine, I'll let you up into the model part, into the numerator of the f-test. There's only one reason you're save a couple terms. It's because for explanation, you have the interactions already in, and since I have to explain the interactions, I'll give you a freebie, let you in. So even SSB is higher than SSC, but there's no need. There's no need, okay? You guys follow me? This is all about writing report, okay? When you write report, try to be stingy, okay? If you look at, I'm just claiming this, okay? When I guide PhD student, my student's dissertation usually is very, very thin, okay? I hate when student write 300 pages long dissertation, okay? This is, okay, so about this argument for the comparison, even though you can do that for 2 blocks or 3 blocks, okay, or for effect, the argument always hold true, okay? What's always hold true? When in doubt, drop it. So the elbow always cut as much as you can. The only time you will say that, so when you cut, there should be in the denominator, right? When you will say that, oh, I'll let you up. Only one conditions. If I keep your interaction term, since interaction is in, okay? And in order to explain that, okay, I'll let you in. Okay? Yeah?
So if you were, like on the homework, you were asked to do the ANOVA table for like all of it.
Mm-hmm.
So would we have like, were we supposed to do like ANOVA table for positive, ANOVA table for negative, and then like the whole model?
If for your homework, I torture you. That's why I have the fractional model, and the full model for you to sense. You know, well, when you finish the fractional model, do you have the sense that using the fractional model, you actually can conclude all the stuff you can conclude in the full model? Did you get that experience? And once you get that experience, would you agree with me that whenever I say doing fractional factorial model can save money, makes sense, right? So in the homework, I can torture you that way. But in the exam, if you only have few hours, that's wasting time. But no matter you're doing fractional model or full model, once you build your sum of square, I do want you to understand that a lot of time the sum of square making the cut, we're cut as much as we can. But once in a while, we kind of like, I'll let a main effect survive. I said it many times. It's because the logics. You cannot talk about high-level interactions without the primary effect first. Okay? That make sense to you? Okay. Anything else? Okay. Yeah. The things I will tell you is that we have 4 hours, right, for the exam.
Yes.
It's not going to be any time for you to monkey around. So in other words, is that you have to look at the problem and find a strategy to do the problems. If you think that you can go back, check the homework, or have some, try if and error, you will be in trouble. The other thing is that I'm trying to come up with some mechanism. If last exam I already see things are very fishy. 2, 3 spreadsheet, actually, they look very, very similar. The right locations for the right computation. I have to speculate. My suspicion is that there are copy paste going out. Okay, and I'll find my way to catch that. And I'll say it on record. If I caught something like this, I'm not gonna deal with it. I'm gonna send to academic affair, let them investigate. So in other words, is that, you know, you can prepare your defense if I send you there. And if they said, okay, it's obviously there are cheating going on, you out of this class, okay? Okay, anything else? Okay, good luck.